Hey folks, welcome to another set of Chemistry 2 video notes. Today we'll be talking about the structure and nomenclature of cyclic hydrocarbons. Fortunately for you, despite the deep waters that cyclic hydrocarbons are, we're only wading very lightly into the shallow end. So let's get started. Let's talk about cycloalkanes first. Imagine a straight chain hydrocarbon, or an acyclic one if you will. Pluck a hydrogen off each end carbon on that straight chain. Then wrap that chain around to connect those two carbons. Boom, you've got a cycloalkane. Cycloalkanes are still saturated, meaning that each carbon is attached to 4 other atoms. And they're cyclic, meaning they form a ring. Some examples of the basic cycloalkanes are cyclopropane, cyclobutane, and the two much more common cyclopentane and cyclohexane. Notice how the name of each of those is just the name of a normal straight chain alkane, but with cyclo in front of it. Cycloalkenes are very similar to cycloalkanes, but they are not saturated. That means that not all carbons have 4 other atoms attached to them. In other words, there's at least one double bond. These are named in a very similar fashion to cycloalkanes. So, to name our whole cycloalkane or alkene, here are some of the rules. You can find a more complete set of rules on your Naming Organic Molecules, a guide, document. So, the normal naming rules for acyclic alkanes and alkenes still apply, but with a handful of special rules as follows. You have to add cyclo before the parent chain name. This tells us that it's in a ring. For cycloalkanes, you start the numbering where there's a substituent. If there's more than one substituent, go whichever way will give you the smallest number for all of the substituents. For cycloalkenes, you have to start numbering on one of the carbons in the double bond. From there, you go to the other carbon on the double bond. Pick these 2 carbons as 1 and 2 in a way that'll give you the smallest numbers for the substituents. In either case, if you determine where carbon 1 is, and it doesn't seem to matter which way you count from there, as far as the substituent numbers go, then go in the direction that gives the more alphabetically favorable substituent a lower number. So let's do some examples. For the first one, let's look at the cyclic part of this molecule. How many carbons are on it? I count 3. So the name of the parent chain, or your root name, will be cyclopropane. Now, which one of those carbons is carbon number 1? Well, the one with the substituent, of course. That makes this 1-bromocyclopropane. It's also acceptable and largely preferred if you forget the 1. Since we could turn this molecule around upside down and flip it over and it still wouldn't change the way we count it, there's really no reason to specify that the bromine is on 1. How about the second one? Our parent chain would be cyclopentane because there are 5 carbons in the ring. Which carbon would I start numbering with? The one with the chlorine or the one with the ethyl group? Either way I do it, I can get my smallest substituent numbers to be 1 and 2. So let's go with the one that comes first alphabetically, chloro. That makes this 1-chloro, 2-ethyl cyclopropane. How about our third example? What would you name the parent chain, or the cyclic part of this molecule? Now let's look at some ways we could number it. There are 6 ways we could number this. Which one would give you the lowest substituent numbers? I would start on the methyl group and then go clockwise. The second group is a funny looking group that you haven't seen before. It's an ethene molecule attached as an alkyl group. So just like when we had ethane as an alkyl group and we named it ethyl, our ethene will name ethylene. So for the name for this one, I got 2-ethylene, 4-fluoro, 1-methyl cyclohexane. All right, you try this next example on your own. What do you get? I got 4-bromo, 2,2-dichloro, 1,3,5-trimethyl cycloheptane. How about some examples of cycloalkenes? What would you call the parent chain on the first one? I would call it cyclohexene. Now you have 2 choices where to start your numbering. Carbons 1 and 2 have to go across the double bond, so pick whichever direction will get you to a substituent first. Now continue numbering. That would make this one 4-chlorocyclohexene. What about the next one? Our 2 choices for numbering are like this. Which one gives us a smaller substituent number? All right, so you name this one 2,3-dimethylcyclobutene. Whew, this next one is a doozy. Here are your two options for numbering. Either way gives you a substituent on 3, 4, and 5, so which way is actually better? Chloro would come alphabetically before methyl, so I would number it counterclockwise. This means the name of this molecule would be 3-chloro, 4-ethylene, 5-methylcyclopentene. All right, try this last one on your own. What do you get? I got 1,3,3-trichlorocyclopropene. Okay, now on to the slightly less reactive, but honestly way cooler, aromatic carbons. Side note, aromatic carbons were first named that because many of them have a pleasant smell or aroma. Aromatic carbons are cyclic hydrocarbons that have alternating single and double carbon-carbon bonds. One of the most common aromatic hydrocarbons, and the only one we're going to base most of our knowledge on in here, is called benzene. The actual structure of benzene is shown on the right over there. The normal line structure you'd probably draw is shown here on the left. And in the middle is a special way that chemists like to denote aromatic hydrocarbons. Since these double bonds in the middle are delocalized, in other words, they can swap places with each other, chemists like to just draw a circle in the middle. And that reminds them that there are alternating, movable, double and single bonds there. To name an aromatic hydrocarbon, at least just the benzene-based ones, the name in the parent chain will be benzene, with only 3 exceptions for your purposes. If there's a benzene with a methyl group attached, we call it toluene. If there's an amino group attached, NH2, we call it aniline. And if there's a hydroxyl group attached, or OH, it's called phenol. If one of those exceptions is the case, then we have to start numbering on that substituent. Otherwise, number it and name the branching groups as you would a cycloalkane, except this time benzene is your root name. Let me repeat that because it's kind of tricky. Even though there are double bonds, since these double bonds are movable, we don't number it like we do on a cycloalkene. We number it like we do on a cycloalkane. Let's do some examples. We don't seem to have a methyl, amino, or hydroxyl group on our first example, so the root name is benzene. Start numbering on one of the substituents, and then continue numbering whichever way gives you the smallest numbers for your substituents. I would call this molecule 1,3-dichlorobenzene. How about the next one? I'd start numbering on the chlorine on the top left, and then work your way around counterclockwise. I'd call this 2-bromo-1,4-dichlorobenzene. How about the next one? There is a methyl group attached to this one, so our root name will be toluene, and we have to start counting where that methyl group is. So I would call this one 3-chlorotoluene. How about the next one? There's an amino group, so this one has a root name of aniline. Would you number clockwise or counterclockwise from there? I would number clockwise. This gives you 3,4-difluoroaniline. How about this guy? There's an OH group attached, so we're going to call it phenol, but which direction would you number from there? Actually, either way you go, get your bromines on 3 and 5. So this one is just 3,5-dibromophenol. All right, try this last one on your own. What do you get? I got 3-chloro-5-fluorotoluene. Well, that's it for today, folks. I hope this video will help you be on your way to naming some cyclic hydrocarbons. As always, let me know if you have any questions.